Happy Monday. It's your last week before fall break. Woohoo! And we're going to be looking at our last approaching proficiency skill today. So let's look at our bell work for today. Problem of the day. We got Dr. Collis here. And Dr. Collis is making a garden for growing vegetables. And he wants to fence it in to keep out the dog. He has 24 feet of fencing. We're going to write an equation to represent all the possible dimensions of the garden if all of the fencing is used. So in order to find how much fencing we're going to use, remember this is going to be perimeter, because it's a round. Perimeter is a round. So we know the perimeter equals 2W plus 2L, so 2 of the width plus 2 of the length. Well, for this one right here, I'm going to make my width equal X, and my length is going to equal Y. Are we told how much fencing we have? We are 24. So I have 2X plus 2Y equals 24. So we've written an equation to represent all the possible dimensions of the garden if all the fencing is used. And let's look at a graph using the X and Y intercepts that show all the possible combinations of length and width that would work for the garden. Remember to find our intercepts for our X, we're going to plug in a 0 for Y. So we have 2X equals 24. So our X-intercept is going to equal 12. So we have 12 and 0. And then our Y-intercept, remember we plug in a 0 for X. So 2Y equals 24. So Y equals 12. Oh, we have the same exact X and Y intercepts. And if you look at this graph right here, you can click on it, or I'll click on it for you. We have our graph of our X and Y intercepts and all the possible combinations that we could have for lengths and widths of our garden fence. So why do the intercepts have no meaning in this situation? Well, can you have a length without a width and actually fence in your garden? No. And can you have a width without a length and actually fence in your garden? No. So these intercepts have no meaning because they just don't make any sense. All right, let's move on. Just a reminder that your approaching proficiency quiz is on Thursday, October 3rd. Now, tomorrow, you're going to have a big Pear Deck practice uploaded for you in the agenda for tomorrow for you to work through that's going to cover all the approaching proficiency skills. You have off on Wednesday. And then Thursday, when you come to class, you're going to take your approaching proficiency quiz. When you're done with your quiz, you're going to have a nice review paper to practice for your benchmark, which you're going to take on Friday. And remember, your benchmark is just 10 questions going over polynomials and equations and inequality knowledge. So nothing to stress out about. Just make sure you get that good practice in on Thursday. So you're going to be watching the video like you are right now about literal equations, and then there's just a nice practice that you'll have a worksheet for. So we're looking at our last approaching proficiency skill, solving a literal equation for a specific variable. So we are on skill number 5 of your packet, and skill number 5 is on page 1, 2, 3, 4 on the back. Now, a literal equation can be any equation that has multiple variables. Literal equations are often formulas, like area, length times width, A equals length times width, or perimeter, which we're going to see right there as our first example. So converting among the forms of linear equations requires the skill of being able to solve a literal equation. So you have to know how to do this. To solve a literal equation, all we do is just follow all the rules for solving an equation, keeping in mind that you can only add and subtract like terms. So we're doing the same thing we do with numbers. We just have a bunch of letters. So let's look at this first one here. We have P equals 2W plus 2L, and we're told to solve for W. Well, our first step is to move this 2L to the other side. So I'm going to subtract it. Now I have P minus 2L equals 2W. Well, to get the W by itself, I'm just going to divide both sides by 2. So now I have W equals P over 2 minus L. The 2's cancel out here. Now I've got my dirt. D equals RT, which is distance equals rate times time. And we're told to solve for T. So I hope you're seeing that we're just going to divide by R. So T equals D over R. T equals D over R. Now for this third example here, we have 2x plus 3y equals 6. We've used this equation a lot already in the CL. And we're going to solve for y. So our first step is we're going to move this 2x over, and we're going to move it over through subtraction. So now I have 3y equals 6 minus 2x. I've got to get the y by itself, so I'm going to divide both sides by y, or by 3, pardon me. So y equals, and then I do 6 divided by 3, which gives me 2, minus 2x over 3. So y equals 2 minus 2x over 3 is our simplified form for this equation. Example number 4, u equals ak divided by b, and we need to solve for a. Since b is in the denominator, I know that everything is getting divided by b, and the inverse of dividing is multiplication. So we're going to multiply both sides by b. So now we have bu equals ak. I hope you realize that we need to divide by k to get the a by itself. So a equals bu all over k. Well, now we're told to solve for y. I have y minus 5 equals negative 2, and in parentheses x plus 1. Since I need to get the y by itself on this side, and I see that I have parentheses over here, I'm actually going to distribute first before I start solving for y. So I have y minus 5 equals negative 2x minus 2. Well, now I see I have to solve for y. So since it's y minus 5, the inverse of subtraction is addition. So I'm going to add 5 to both sides and only combining like terms. So y equals negative 2x plus 3. Y equals negative 2x plus 3. And finally, we have g equals x minus c plus y. Well, we're told to solve for x. So my first step is I'm going to add c to both sides. So now I have g plus c equals x plus y. Well, in order to get the x by itself, I have to subtract y from both sides. So now I have g plus c minus y equals x. So when you solve literal equations, you're doing the same thing you would do to solve equations with numbers. You're just getting whatever variable you're told to get by itself. All right, and that was the end of everything for our approaching proficiency skills. Now, if you're still having problems and you're not quite getting it, I've got this other variable, or this other video linked for you to watch if you need a little more practice to see how to solve for literal equations. If not, and you're feeling pretty good about it, the substitute teacher will have a copy of the worksheet for you to work on. And you can check your answers right here as well. So this is what you're doing. You've got about 16 different literal equations to solve. If you have any questions or are starting to freak out or panic, please reach out to me through email and I will get to you and help you out. Have a good rest of your Monday.